Well, today we're going to be solving proportions. There's a couple different ways we can solve a proportion, and we're going to go through two of them today. So let's get right to it. So here's a proportion. And remember, proportion is really just two equal ratios or two equal fractions. So when we look at this, we can say that 3/5 or 3/5 is equal to 9 over some number. Now, a lot of you that have the number sense, you'll see and you'll kind of figure out what it is right away. But I want to show you how you're actually getting there. Okay. What we want to do is we want to be able to scale this up. And what I mean by that is if we recognize that 3 times 3 is equal to 9, what that means then is that 5 times 3 is going to be equal to x. So in this problem, we could say that x is equal to 15. And when we look at it, we say 3/5 is equal to 9/15. And we can see that that's true because if we reduce 9/15, we'll get 3/5. Okay, but what happens when the numbers don't work quite as well? I'm going to show you the same problem, but we're going to do this a different way. We're going to do this using what's called the cross product method. And cross product is exactly what it sounds like. We're going to find the cross products of this proportion. So what we would do is we would multiply x times 3. So that's going to give us 3x. And that's going to be equal to 9 times 5. Or let's say 9 times 5. So basically 3x is going to be equal to 45. And then to solve that, we would divide both sides by 3, and we would find out that x is equal to 15, just like we did before. So let's see how this works for another problem. If you look at it, you really can't scale. Like you could, but it's not a real simple thing to do. You would have to say 4 times something is equal to 7. And it's not something that comes to you right away. So we're going to use the other method, the cross product method. Now, this is one of those problems where you're going to be tempted to say, well, wait, I have a 4 and I have an 8. I want to reduce that. Well, you can't because you're not allowed to reduce across the equal sign. Okay, remember the equal sign is kind of like a barrier there. You can never reduce across the equal sign. So what we're going to do is we're going to solve this using our cross product method. So again, we're going to say we have 8 times 4. So that's 32 is equal to n times 7, which is 7n. And then we have to find out what n is. So we would divide both sides by 7. And we would say that n is going to be equal to 32/7. And again, we could turn that into a mixed number if we choose to. Okay, so let's make that 4 and 4/7. And that would be equal to n. Okay, let's go to the next level of problem, one that's slightly more difficult. Proportion. This time it's not just n we have an n plus 2, right? If we look at it up here, you could see that's not just an n. All that does is that just adds another step to the problem. Doesn't make it harder, just adds a step. So again, we could see that this is not going to be one of those scaling problems. There's nothing easy to multiply n plus 2 by to get 8. So what we want to do is we want to find our cross products. So I'm going to write this one out this time. And I'm going to say it's 11 times n plus 2 is equal to 5 times 8. So that gives me 11n plus 22 is equal to 40. And then again, we'll solve this just like we've been solving. So we subtract 22 from both sides. And we get 11n is going to be equal to 18. And then divide by 11. So we know that n is equal to 18/11. And we could say that it's the same as 1 and 7/11. Okay. But if you're working in algebra, many times you're going to be much better served if you leave your answer as an improper fraction than if you try to turn it into a mixed number. Because if you're going to turn it into a mixed number, there's a lot of times where you're then going to have to turn it back into an improper fraction to do an